Okay, this is a lab on physical versus chemical changes. So we're just going to go through a bunch of examples. I'll show you the example. I'll pause so you can turn off the video if you'd like, and then I'll give you the answer. Okay, our first item is very simple. We have a piece of paper here, and we're just going to tear it. You can see, tear it in a couple pieces. Is that physical or a chemical change? Well, as you can see, the paper is still paper. There's nothing new formed. So this is a physical change. Yes, you can see some rough edges, but paper is still paper. The next example is we're going to take a match. Okay, I'm simply going to light the match. And here we go. You can see smoke there, yellow color. It was red, now it's black. Let's put it out. Again, lots of smoke. And a black ashy color. This is clearly an example of a chemical change. There's a new substance formed. You can't relight this match because it's different than it was before. The sulfur's burned off it, some of the wood's burned, and the ash is there. All the smoke was given, so a lot of indicators that a chemical change took place. Okay, next I have a beaker with some sugar in it. And what I'm going to do is I'm going to add water, and we're just going to mix it around. Okay, so I added water. And I'm going to stir it around. And if all goes well, the sugar is going to disappear. We call that dissolving. So is dissolving a physical or a chemical change? Okay. Most of the sugar is pretty much gone. Well, if I were to taste it, which I'm not going to because these beakers are filthy, if I tasted this, it would be sweetened water. So sugar and water. So there's still sugar, there's still water, nothing new has been produced. So this is a physical change. The next example is using a mortar and pestle. And what I did, you probably can't see it on the camera, but I put salt crystals in this mortar, and I'm just going to grind them up. It's called mortaring. I'm going to grind them all up in there. Now you can look in there and you can see it's all powdery up now. It was crystallized. Now it's kind of like fine powder. So again, I'm not going to taste this because it's dirty, but there's still salt there. If I taste it, it'd be salty. The salt hasn't changed into anything new. So again, this is a physical change. Next example is a balloon. And I have a pin here. I'm going to use this pin on this balloon. We're going to put it right into the balloon here and see what happens. Right there. As you can see, hey, nothing happens, okay? There's a reason for that. Anyway, let's try putting it in a different spot. I'm not going to look at this one. What kind of change was that? You still have the latex from the balloon. The air is all gone. But again, physical change. Nothing new is formed here. Just a different shape or a change took place. Now we're going to do one that's a little more dangerous. So before we do it, I need to get some goggles. The next change we're going to do is we're going to mix some acid here. I have some hydrochloric acid, which is very strong. Probably can't see it from there, but even when I open, the smoke comes out. Nasty. I've got water here. And there's a saying that says, do as you oughta. Add acid to water. So we're going to add a little bit of acid to the water. You probably can see the smoke there. This is dangerous stuff. I diluted the acid because we don't need it full strength. Now I'm going to put it in this flask here. And inside that flask was some aluminum foil. I'm going to put a balloon on top of the aluminum foil, and then we're going to take this to the fume hood. Now this is going to take a few minutes. I've got aluminum foil and acid in there. And this is an example of activation energy. But if you look closely, I don't know if you can see it on the video or not, but there's bubbles being produced in there, and that's something that's important to look for. And the flask is getting warmer. Okay, so there's bubbles in there, and which is a sign of a chemical change already, something new is happening. There's activation energy going on. It takes some time for this to happen. It's got to overcome the activation energy. You see a lot of bubbles now. And pretty soon I'm going to let go of this. There it goes. Start to see something happening here. We'll put her, oh, it's getting pretty violent now. See the bubble action? I'm going to put it there so I don't get hurt. Pretty violent reaction. That's probably about 400 degrees, and it happened very quickly. Let it settle down for a second. Okay, I've hung the balloon from a place, and I'm going to light a wood splint here. I don't know if you can see it. And I'm going to light that balloon, and we'll see if there's anything in it. That balloon, if it had just oxygen, would not have flamed up like that. So it's clearly that there was a gas inside that balloon. In fact, that gas is hydrogen gas. When you add an acid to a metal, it produces hydrogen gas, and that's certainly a chemical change.